So for a good chunk of the test is to, hey, differentiate this stuff. I only care about the first step. There's no simplification required. So just do the derivative, bam, you're done. So in A, the derivative, wait a second, I gotta change my pen. So in A, the derivative, you're just gonna give me 3 plus 2x. I don't need anything else, okay? I just need that first step. Not at all. For B, that would be 15x squared plus secant squared of x. For C, you have to use, there's two pieces of this puzzle. There's a product rule, but there's also a chain because the sign of x has something stuck in it. Okay, so let's put a little dot there, and let's just highlight that too to remind me there's stuff there. Okay, so when we do the derivative of that, it's the first times the derivative of the second. Now, the derivative of the second, so it's the first times the derivative of the second. Now, the sine of 2x is the cosine of the stuff times the derivative of the stuff. The cosine of the stuff times the derivative of the stuff. So the stuff is 2x, the derivative of that is 2. So don't forget to tack on that 2 there, okay? Plus the second as is times the derivative of the first, which is just going to be 6x squared. I just kept the 2, keep the 2 with something. Keep the 2 with one of the pieces. I tend to put it with the 2x cubed as one thing. So let me go over that again. It's the first times the derivative of the second. That is a cosine of the stuff times the derivative of the stuff, okay? Plus the second times the derivative of the first. So hopefully that reminds you how that works, okay? Now, for part D, surround your top and bottom in parentheses first, and then let's go ahead and do the quotient rule. Again, there's no simplification necessary. We're just going to do the quotient rule, and whatever happens, happens. So it is the bottom times the derivative of the top, which is 4x cubed plus 6x, minus the top. I am totally running out of room here. Let's condense that down a little bit. Times the derivative of the bottom. Now the bottom has a chain rule in it because inside of the secant we have something. So we have to use a chain rule. So times the negative sine of x. Now the secant is the secant tangent of the stuff. So you write the secant of 2x, the tangent of 2x, times the derivative of the stuff. I'm so close. Oh, okay. It's the tangent of 2x. Sorry about that. All over the bottom as is squared. Okay, so let me go over it again. Bottom times the derivative of the top minus top times the derivative of the bottom. The bottom is a negative sign. This is a secant and a tangent of the stuff. That does say 2x in both of those. Times the derivative of the stuff. All over the bottom squared. It is terrible, but it's just the quotient rule. But there's a product or a chain in there because the secant has something in it. Yeah. Yes and no. There are some shortcuts, and I'm going to teach you some rules how to simplify them in a nice way. Usually we're only concerned about what our numerator looks like, so we usually don't touch or simplify the bottom. So we are going to eventually have to simplify the top, and I'll show you some tricks when we get to it. Now, for part E, we want to do a rewrite, which doesn't count as a first step. We want to write that as a 1/5 power before we do anything else. Okay, so for E, I'm going to do that rewrite. I'm going to get it all ready, and then I'm going to differentiate. So my derivative is a chain. Drop the 1/5 in front, leave the stuff there. The power goes down by 1. So remember that 1/5 minus 1 is 1/5 minus 5/5 or negative 4/5 times the derivative of the stuff. So that's going to be 6x. Now the cosine has a stuff in it, so it's going to be negative sine of the stuff times the derivative of the stuff. Okay, so that is E. Now F, they have rewritten it in a good way, I guess, as much as that problem is good. Put a dot between them to remind yourself to use a product rule. Now it's a product chain. The chain is a power chain, so it's not a really disgusting chain rule, but you do have to remember the chain rule. So F, I'm going to write it as the first, leave it alone, times the derivative of the second. Now that's a chain rule. The 10's going to drop down in front. The stuff stays there. Power goes down by 1 times the derivative of the stuff. So 6x to the 5th plus 6x plus the second times the derivative of the first. So that first, the 5/2 drops down in front. The stuff stays there. The power goes down by 1. 5/2 minus 2/2 is 3/2 times the derivative of the stuff that was stuck inside. So 5x to the 4th plus 3. Okay, so let me go over that again. First times the derivative of the second. The second one, the 10 drops down in front. Power goes down by 1. Stuff stays there times the derivative of the stuff. Plus the second times the derivative of the first. Power goes down in front. Stuff stays there. Power goes down by 1. Don't forget to take the derivative of the stuff inside. That's a lot. Yeah.
That's going to be on the test?
Yeah.
That big of an equation?
Sure. I don't know. I don't even know where the test is. I don't know. I mean, yeah. Give me one step at a time. I know. Okay. So there's a few different tactics to use for G. Some people like to write it like this, the top cubed and the bottom cubed, and then do the quotient rule. You know, bottom times derivative of the top minus top times derivative of the bottom squared. I don't. I just do it like I'm going to show you, but feel free, if you like that, go for it. I don't care. What I usually do is I treat it like a power chain rule. I drop the power down in front. I leave the stuff there. My power goes down by 1. And then when I multiply by the derivative of the stuff that was stuck, when I do that, it's just a simpler fraction that I'm taking a quotient rule for. I mean, you don't get out of the quotient rule. You still have to do the quotient rule, unfortunately. But you don't have chains or anything to deal with. So I don't do, like, yeah, I don't use that. But so then it's just bottom times the derivative of the top. Let me move this down so I have room. bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. Now, you can do it either way. If you did the quotient rule to this, I'll give it to you. If you did the quotient rule like I did, or power quotient, that's fine. I don't care. You might look at it and see one thing, and I might see something else. I've seen some people that actually even make it x cubed minus 2 cubed times x to the fourth plus 1 to the negative 3, and then they use the product rule. So that is also an option. So you can leave it as is and do what I did. You can make it a top and bottom clearly quotient rule problem, or you can make that thing that was in the bottom to the negative power and do a product rule. Either of these things will work. There's so many methods to do these problems. So I'll just look and try to follow what method you've used, and I should be able to figure out if you did something different than I did, that it's still correct. So feel free, if you see a rewrite that makes more sense to you, go for it. It doesn't matter, okay? Now, let's move on now to H. The first thing you want to do is rewrite that as x cosine of 3x to the 1/2 power. Okay, so that has to be done before I can do anything else. I'm going to leave it as a chain. So I'm going to drop the 1/2 down in front, leave the stuff. My power is going to go down by 1. Just remember that 1/2 minus 1 is 1/2 minus 2/2 or negative 1/2. But don't forget, inside is a product that I have to do the product rule for. So it's going to be first times the derivative of the second. So I'm going to put just the negative sign of that stuff times the derivative of that stuff plus the second times the derivative of x, which is just 1. So you could put the 1 there if that makes your head happy. Put a 1 there, go for it. That's fine by me. We haven't done those yet, so we're going to skip that, I and J. We'll do those eventually. They're actually one of the easiest rules. Like the derivative of e to the x is e to the x. Yeah, you know what I mean? So they're nice rules. The derivative of a natural log is like 1 over x. Those are just going to be some rules, new rules we have to learn. We just haven't done them yet. YSU doesn't do them. Kent does. Eastern Gateway does. So it's just a matter of who does them, who doesn't, when to do them. I'll get to them. We are going to do them this year. I just don't know when. Okay, now we're going to jump to K. Put a dot between those two to remind you that's a product. This is a chain. Okay, but it's not a horrible derivative. The derivative of that, it's first times the derivative of the second, the derivative of a secant is secant tangent, plus the second times the derivative of the first. If a 2x is coming after a secant of x, I do put it in the whole thing in parentheses so it looks like those things are separate things that are being multiplied. But however you want to denote it, parentheses is a helpful way. Okay. Plus the derivative of a tangent. The tangent's derivative is secant squared. So it's the secant squared of that stuff times the derivative of that stuff. And again, you could probably do that. You could even put like a separating parenthesis around that if you want. You don't have to. If you clearly put the dot there, I know what that means. Okay. Now let's go to L. Now it says to find y prime. You'll notice that our x's and y's are all mixed up. we're going to have to use implicit differentiation. Every time we take a derivative of a y, tack on a y prime. That's the only thing you have to remember. If it's a y that you've just taken the derivative of, tack on a y prime, okay? So we're going to put a dot between all the pieces that have both x's and y's in it because we have to use the product rule for those things. Okay, so it's going to be the first times the derivative of the second. It's normally 1, but it's 1y prime because it was a y, plus the second times the derivative of the first. The derivative of 7 is 0. The derivative of y squared is 2y, but it was a y, so I tack on a y prime. The derivative of xy, I have to use implicit, so first times derivative of the second plus second times derivative of the first. It's a product rule. So first times the derivative of the second plus second times the derivative of the first. X is x. We're taking the derivative in terms of x, so it's just 1. And then the derivative of x is just 1. Now, if you get there and this problem is worth 4 points, you're getting 3 out of 4. You're good to go. The only problem next to get that final full credit is to solve for y prime. So all of the things that contain a y prime, we're going to take to one side. The things that do not contain a y prime, put on the other side. Okay. So all the ones that I've highlighted in yellow contain a y prime. Let's put those on the left and the others on the right. Now, it doesn't matter which, go for it. I don't care. I will notice the difference. You'll get like the opposite signs versus my top and bottom. It doesn't matter. It'll work. Okay, anyway. So x cubed y prime minus off the 2y prime minus off the xy prime. And then I have y plus 1 that I'm subtracting off 3x squared y. Now, I do usually put the variables alphabetically, but it doesn't matter. Now, these terms on the right all contain a y prime, but they're unlike terms. You notice one has a cube and one has a y and one has an x. Not anything I can combine. So don't worry about that. Just take out the y prime by factoring, okay? So we get x cubed minus 2y minus x. You've got it. The answer is staring us in the face. All we've got to do is divide both sides by that parenthesis and we're done. So that's all you do. Divide it, put it on the other side, bam, we're done. So y prime is the right side, y plus 1 minus 3x squared y, over the parenthesis. Now you can put the parentheses on, but if you put it clearly under there, you don't have to, but feel free if you want to put the parentheses. That's y prime. You always do the same thing. So let's go over it again. We're going to take the derivative like normal, but every time we do a derivative of a y, tack on a y prime. All the terms that contain a y prime go to one side. All the terms that have no y prime go to the other. Factor out the y prime. Whatever in parentheses needs to go to the other side and divide off. We got it. Okay, that's it. You should know how to do that. It's not, don't overthink implicit. If there's a y prime and I did a derivative, if there's a y and I did a derivative, tack on a y prime. Get the y primes to one side, non-y primes to the other, factor, divide. Do the same thing every time, okay? Everybody good with L? Okie dokie. We're going to change number 2. I just need a different equation. To the equation y equals 2x squared. I'm thinking. 2x squared plus 3. Again, that requires us to know how to do logs and exponentials. We don't know that yet. We'll get to that. I think maybe next chapter. I don't know. Anyway, so it says find the equation of the tangent line through the point 1,5 to the curve y equals 2x squared plus 3. You always want to follow the same steps. First step is find the derivative. Second step, find the slope of the tangent by plugging in the point that you've been given. Third step, you use the point and the slope in the point slope formula. Y minus y1 equals m times x minus x1. So really, that's the steps you should take every single time you're asked to find the equation of the tangent line. If it was an implicit one like L, you'd still find y prime. That would be your first step. You would still plug in the point for number 2 to find the slope. You would still use y minus y1 equals m times x minus x1. So don't overthink these problems. Okay, anyway. So the first thing we do is we take the derivative, which is 4x. Second thing we do to find the slope of the tangent, we use that formula to plug in the x value that we've been given, because that, remember, is the formula for the slope of the tangent at any point. But we need the 0.15, so our x value is 1. So that's 4 times 1. Our slope is 4. So then we just use our point slope formula. So our point is 1, 5. Our slope is 4. So it's y minus 5 equals 4 times the quantity of x minus 1. Don't worry about putting that in slope-intercept form unless that makes your brain happy. I don't need you to go further. I know you're sitting in calculus. You know how to rearrange that formula. Okay? So leave it the way that it sits right there. Are we good with question number 2? Okay. Finally, question number 3. It says a particle moves with the position function that is given. What is the velocity? What is the acceleration? When does the particle stop? What is the starting velocity? So let's talk about the velocity and the acceleration equation. If we know our position function, if we take the first derivative, that's our velocity. If we take the derivative again, that's our acceleration. Okay, so all you have to know is that it goes in the order: position, first derivative, velocity, next derivative or second derivative or first derivatives of the velocity, however you want to think about it, is the acceleration. So know that order. In this chapter, we're going forward in that order. In the next chapter, we'll go backwards, or eventually we'll go backwards. I don't remember when. Maybe the chapter after that. Maybe chapter 4. Anyway, the velocity equation, all that we're going to do is take the derivative of the equation that we saw before. So 2 minus sine of t, that derivative is 0 minus the cosine of t. So that's good. Our acceleration equation, you just do the derivative one more time, or the derivative of the velocity. A negative cosine would become a negative sign, or the two negatives cancel out, and so that's why it becomes a positive. When does the particle stop? That is when our velocity equation equals 0. So where is the cosine equal to 0? Now let's think about our cosine. Our cosine on the unit circle is our x value. Our x value becomes 0 at 90 pi over 2, then down again 3 pi over 2, and then 5 pi over 2, or going backwards. So it's every 180 degrees from a pi over 2. So how do you write that? So, and time, this is time. This is time. Most likely seconds, I don't know. Like that might be feet per second or whatever. So time has to be greater than or equal to 0. So we only have to consider the positives, because the cosine is a never-ending function. It goes all the way to the negatives and all the way to the positives. There's no gaps or jumps or problems with the cosine. So we really just have to go in the positive direction, loop around the unit circle. So time would be pi over 2 plus n pi. Now let's talk about what that means. It means that every 180 degrees, so n is an integer. Excuse me. So if I add 0 pi's onto pi over 2, if I add 1 pi, 2 pi, and actually it has to be a positive integer. Ooh, let's call it whole numbers. So we can do 0. Whole numbers, is it W? What's the abbreviation for whole number? What's Z's integer? What's a whole number? We're going to call it W, but I don't know if that's what the abbreviation is off the top of my head. I don't know why I can't think of that. But anyway, so that would be a whole number. So if we add 180 onto 90, or we can add 360, or we can add 7, I don't know. What's after that? What's 180 plus 360? 540 we can add on, all that stuff. What is the starting velocity? So all they're asking us is to take our velocity equation, plug in 0. These are easy, actually, once you know how they're all connected. The velocity at time 0 is just the negative cosine of 0, or -1. So that might be that it's slowing down, or going backwards. There's lots of ways. It depends upon what it's looking at. So that is that. Turn this in for me. Huh? It is? Oh, thank you. Good. Okay, so there you go. Turn that in. Tomorrow we're going to review some more.